Hi, my name is Phil Trombley for the RIDGID Tool Company, and today I'm going to walk you through our 10-watt line transmitter, the ST510. For sake of comparison, I brought its little brother, the 305, which is a 5-watt unit, which is all you'll ever need. But for those individuals doing larger diameter pipeline work, water supply, cast pipe, etc., this is the tool of choice. Twice the power, twice the capability of pushing a signal down the line. Okay. First things first, requires 8 D-cell batteries, which conveniently fit in to the back of the unit. Okay, so we'll walk you through the features of this unit. Basically, terminal lead. These are approximately 50 feet long. Stretch out forever. Okay, so very convenient. Okay, and again, no polarity. One to the ground, one to the utility. Okay, if we go over the dash, here we got our controls. The on-off button, volume control, the menu button, which gives you the capability of dialing the frequency to competitors' units, which is very convenient. The inductive mode button, which we'll discuss a little later. We have the up power key and the down power key, and these are frequency selections. Again, 4 buttons, 5 frequencies. Let's turn it on and see what it looks like. Nice LCD dash assembly, and if you take a look, white LED indicating we're at 128 Hertz. Other choice, 1 kilohertz. Other choice, 8 kilohertz. Other choice, 262 Hertz, European frequency, which we can use here, and 33,000 Hertz. So the way the inductive mode would work is that you would be carrying this out in the field, okay, so obviously above ground, in the hope that you can basically find a conductor below ground, like a pipeline, etc. So in this case, just illustrate this pipe with a piece of conduit, and what would happen is that the signal from the north and the south pole would basically drop below ground, concentrate where there's a conductor, and come back, and whoever's on the locator about 30 feet away could basically determine if he's reading the signal through the ground. So that's a quick look at inductive. So we're outside and we're just going to kind of show you how to set this up. It's pretty simple. In this instance, we're going to use the ground rod that's supplied. And when you look around a paved area, etc., look for the grass that grows between the cracks. And that should give you the capability to plunge this with sufficient contact area to hopefully create a good ground. So again, the rule remains the same. We clip to the ground rod first, so that way if there's any live current on the utility, 250 volts is it's capable. Clip to a vice grip, because in this case the utility has no tracer wire. And if we have a circuit, the dash should confirm the resistance in the circuit and basically the power. We can hear it beeping. We're here just to kind of illustrate the use of the power setting on the tool, which will either maximize your battery life or, for that matter, push the signal further down the conductor. If you take a look at our dashboard, it's set at the lowest setting. Okay, by pressing the up arrow, it's going to incrementally bring it up to another setting, 25 milliamps. And we can again press it again and bring it to 10 milliamps, and so on. And so effectively, depending on the resistance in the circuit, it will determine the maximum amount of amps required to operate the tool. But this is basically how you can maximize your battery life, or for that matter, maximize pushing the signal down through the conductor. So that's the power controls. We're back inside, and what I want to just discuss real quickly is why do we provide you 5 different frequencies to operate the tool? The answer is simple. Depending on the quality of the substrate, the conductivity of the soil, and the conductivity of what you're trying to trace, be it an exposed tracer wire, or large diameter cast pipe, an underground pipeline that's been in the ground for 50 years, that's why we provide you different choices of frequencies. And again, the logic is the same. Okay, basically 128 Hertz is the lowest frequency energy that we have, which the tool is set at right now, and then we could step it up to 1 kilohertz, which is 1,000 Hertz. Step it up again to 8 kilohertz or 8,000 Hertz, and go for 33,000 Hertz, which is obviously a lot more coiled energy in that spring, if you imagine 33,000 folds in the same distance. Okay, and of course we have 262,000, okay, which is very high energy, but however dictates a lower wattage because of the FCC rules. So again, who would be the typical end user for this unit? It would be someone doing pipeline or water supply, cast iron, large diameter work going between hydrants and services of the like. with large exposed pipe diameters. This would be the tool where the additional 10 watts power capability would make your locates and your life easier. Thank you.